So welcome back. In the last lecture, we solved half of the problem, right? So we figured it out, like how server sends update to the client, like using polling, SSC, or WebSockets. But there is a deeper question we haven't answered yet. How does the server even know that something changed? Okay, let's understand this with some example. But here we are going to talk about how from the client will reach to the server where the user 2 is connected. Okay, so and this is we are going to call second hop. So first hop we already solved. So let's take one simple example now, chat system. So what I'm saying, there is one user A. He wants to send one message to user C. So user A suppose connected to server 1 somewhere, sticky session, you remember, right? So server 1 is connected now. User C already connected to some server, so let's say it's connected to server 2. Okay, because it's already chatting somewhere else, right? Now this bridge, how the server 1 know this message has to go to the user C, and user C is having the session on server 2. So how this communication is going to happen? How does server 1 send that message to the server 2? This is the core problem in the second hop that we are going to talk. Okay, so we need a routing mechanism inside the backend. So let's try to evolving this step by step. So what should be the naive solution? Okay, though it is not recommended, but let's talk about that. So whenever any message is coming, we are going to store that in database, and server keep checking like database for the updates. Okay, so user A is there and one server is there, and I'm going to save this chat in the DB. Server 2, what will do, it will keep polling this DB. Okay, is keep polling DB and fetch the message, and once it got the message, it's going to send to C, user C. Okay, so this is a bit similar to polling, but on the server side. Here server is polling the DB, right, not the client. So this is similar to polling, but on the server side. So what is the problem in that now? This approach has serious issues. First, it's not real time. So delay depends on the polling interval. You must have to configure that. Second, heavy database load. Every server constantly querying. So suppose you are having 5 servers, so each server is constantly querying the DB. So it's heavy database operation is going on. Third one is the, let me write the second one, high DB load, right? Third point I was talking about, inefficiency. So most queries return nothing, because if chat is over, still you are kept on polling, so you are going to get nothing, right? So clearly pull based approach is not good for the real-time system. Okay, this is pull based approach. So pull based approach is not good for real-time system, right? Okay, so now we are going to flip the thinking. Okay, instead of pulling, what if we push the update? Pull is gone. Now let's talk about the push. What if we push the updates? So what we are going to do, what if always knows, already knowing that which server a user is connected to. Okay, if you somehow got the information user C is connected to server 2, then your work is easy. Then you can directly send the message to that particular server, right? So we have to identify if user C is connected to server 2, then user A want to send the message to user C, then user A send to server 1, because it is the user A is connected on the server 1. So server 1, server is going to finds the hash of user C to find out his server, and is coming as 2. So server 2, suppose it is pointing server 2 and then user C. So what we are doing now, we are calculating the server ID based on the hash of the user ID. Okay, so this ensure same user always map to the same server. So easy routing, right? Because if this user is coming to want to connect with anyone, so its hash code is always same. So server ID will be always same. So we have ensure here like same user always map to the same server. This is not going to change, and this become easy routing. But if number of servers changes, because in scaling today we are having support 2 servers, maybe due to load increase, you are going to scale and you are having now 3 servers, then what? So user again must reconnect to the new server, and this caused massive disruption. So we are okay with that, right? We are on the same page. If this hashing, because hashing depend on the number of server, okay? So like user ID modulo, I'm going to take n, okay? So n is nothing but number of server. So if server change, then the hash is going to change. Server will be again is going to reconnect to the new server, right? So we need a smarter version of the hashing. So here comes one concept, consistent hashing. Okay. So instead of modulo, we are going to use hash ring. We already have discussed this in the previous one of the section. Okay, so you can go in details in that particular lecture. Here I am just talking about the on the 1000 feet of the this concept. So instead of modulo, we are going to use one hash ring. Okay, so like suppose you are having one hash ring. Here is server 1, server 2, server 3, okay, and server 4. Server 3 here, this should be let's put some users also. So I'm putting here user, so might be this is user A and this is user C. User want to A to connect to C, okay. So this is hash ring, we call it hash ring. So user and server are placed on a ring. Each user connect to the nearest server in clockwise, okay. In clockwise, each user is connected to nearest server in clockwise. So user A is connected to server 1 and user C is connected to server 3, right? Now if we add or remove the server, only a small subset of user going to move. If suppose I'm going to remove this particular server, then what will happen? All the user that was coming from here to user, and I mean all the user that is coming from okay, let's take one more example. Suppose let's keep some more user here so that we can use this concept well. Okay, suppose one user is here, user D. So what will happen if I'm removing the server 2? So earlier user D was connected to user C, and one more user was here, user E, and user E is connected to server 2. Server 2 is gone. Server 2 is gone. So what will happen to the user T? User E is going to reconnect to the this server, server 3, because in clockwise this is the nearest server now. So only this portion is going to be impacted, not the whole ring. Okay, so this going to advantage that is a minimal disruption is going to happen, and it scales smoothly and work with the WebSocket also, right? So but still we are having some issue in that. It's a little bit complex to manage, first thing, and require the coordination, and that coordination this can be handled with a third party. Like if suppose you are using the Kafka, then zookeeper is required, which coordinate all these nodes, all this adding and removing of the servers. Okay, so this is useful, but this is not one of the most flexible solution. Okay, so now we are going to move one more smart solution, that is PubSub. And this is what people is in the industry, they are following this. Okay, this is widely used. So instead of trying to track every user, we change the architecture completely. We introduce one middle layer. Okay, so that middle layer is nothing but one PubSub system. Okay, so PubSub system we are going to introduce. So now let's understand this slowly. So user C connect to the server 2, right? User C connect to the server 2. Server 2 register interest in the user C. Okay, so one registration is happening. So server 2 registers interest in user C. It means I want all messages for the user C. So this is called subscription. Okay, so now when user is send a message, server 1 does not try to find out the server 2, like where user C is connected. Instead, is publish the message to the topic. So when user A send this message, so we are not going to find out like user C is connected to server 2, then send the message to the server 2. No, we are simply going to publish this message. Okay, so message is not published. So let's see that now. So what will be the flow now? So user A is there, user A connected to the server 1. Okay, and I have introduced one layer like PubSub somewhere in this place, and then it's published the message now, because it will go to the server 2, and server 2 is connected to the user C. So user C will get the message. So let me explain this flow again. So in step 1, what is happening? User C connect to the server 2, and server 2 subscribe to the topic user C. Okay, this part. Then user A sends a message. Server 1, since already connected to the server 1, it publishes the message. Okay, so when someone is publishing the message, so this message is going to be received by server 2. Okay, it's a WebSocket connection, you can say. So now server 2 send message to user C via WebSocket. Okay, so now you have to just notice here, server 1 does not need to know where user service is connected. PubSub handle this routing automatically, and this is the very massive simplification in this approach, right? So we just decouple the system. Producer don't know the consumer, consumers don't know the producers. Okay, everything is connected via one PubSub bridge or PubSub connect model, and that's why this is the most widely used approach. Okay, so this is very good part. So once you go through this, if you feel somewhere you are stuck, you're not able to understand this communication, just put that question, the question and answer section. I'll be taking care of that and try to explain in a simple way. Okay, so let's put everything now together, whatever you have discussed in the last lecture, also in the current lecture. Okay, so in the first lecture we discussed first half, that I'm talking about server, then client, then WebSocket. Okay, second half we connected source, server, and this is handled by PubSub. Okay, remember that. So final system is a combination of WebSocket and PubSub. Okay, so user A is going to connect the API server is going to connect to the PubSub system, and then WebSocket server, then message went to the user C. So this is the architecture we used in WhatsApp, Uber or live notification or multiplayer system. So this is the standard design. Okay, so today we close the second half of the real-time problem. So we explored multiple things like why pull based system failed, why simple hashing breaks, what is the consistent hashing and how this is going to improve the stability, and finally how PubSub solve the problem cleanly. So we have a complete system now. Okay, so this is all about this. So let's move to the next topic.